Hi, everybody. It's Monday, and I'm at the orthodontist and some stuff with my kids. I'm here in spirit, but not physically. We're in statistics, and it's our day 2 lesson. Our learning target, I'd like you to write this down. Our learning target is I can determine possibilities with permutations. Combinations is what we're studying today, combinations, and the fundamental counting principle. We're going to put all these things together. This is all in section 11.1. What I'd like you to do is figure out right now, how many different words can we make using the letters M-A-T-H? This is going to bring you back from Friday. Mrs. Bott, if you could please pause this and let the kids take a stab at this, and then when everybody's ready, we can join. So go ahead and pause. All right, we're back. So how do we do this? Well, we've got 4 letters. We have position, maybe it's position 1, position 2, position 3, position 4 for my letters. How many choices do I have in the first position? Well, I can pick 4 different letters. Now that I've used one, what can I do? How many choices do I have for the second position? I have 3. When I'm in the third position, how many letters do I have to pick from? 2. And last but not least, I have 1 left. And what we do here is we multiply. This is 4 times 3 times 2 times 1, which is 24. There are 24 different words we can make using the letters M-A-T-H. This is assuming that every combination of those letters is an actual word. Okay. Today we are going to talk about combinations. Combinations are different. They are very different from permutations. It can be a little tricky, so we have to pay attention when we read. We have to use those close reading skills. Combinations, please write this down. They are the number of groupings possible when order doesn't matter. Order doesn't matter. So, order doesn't matter. If you need to pause at any point, please, Mrs. Bott, go ahead. Okay. We've got a formula for combinations. The formula for combinations is the number of combinations of n items chosen r at a time. N items chosen r at a time is this. We can find this in our calculator, just like we could find permutations in our calculator. It's in a different spot depending on what calculator you have. You can certainly Google that. I will demonstrate for the TI-84. And for those of you who have an Inspire or the Little 30, I would have showed you. It's the same spot where your permutations were. Okay. Notice that n has to be greater than r, which has to be greater than 0. It doesn't make sense to choose nothing, and it doesn't make sense to choose more than what we have. So I want you to calculate the number of combinations of 5 choosing 3. The number of combinations of 5 choosing 3. So we're going to plug in the formula. We can do this by hand. This is my n. This is my r. So my number of combinations here are going to be 5 factorial over 3 factorial, 5 minus 3 factorial. So I end up with 5 times 4 times 3 times 2 times 1 all over 3 times 2 times 1. And that's going to be, this simplifies to 2 factorial. That's 2 times 1. So I can go through here and I can simplify. 3 times 2 times 1 cancels with 3 times 2 times 1. So I end up with 20 over 2, which is 10. Okay, you can confirm that using your calculator. I'm going to pull up our calculator. This is how we use it in the 84. Turn this on, and I'm going to show you where it is first. It's under your math button. You arrow over to probability, PRB, and if you notice, Choice 2 is NPR. Choice 3 is NCR. If you do this, nothing works. You've got to actually put in some numbers. You get a syntax error. So the first thing you have to do is type in the number 5 because we're doing 5. Choose 3. So 5, math, probability, combination. My R was 3. Hit enter. It spits out 10. So good for you guys. I know my math. Okay. Let me change this. I would like you guys. Okay, so I think we're good there. All right, I would like you to take a minute and I would like you to write this down. You guys can pause this, take as much time as you need. Okay, you're back. This is the way combinations show up in real life. A college business major can also minor in computer science. And they can major in computer science if they take any 7 courses from an approved list of 10. So my total's 10. I get to choose 7. So my formula for that, this is N, this is R, 10, choose R, 10 choose 7. And if we plug that in our calculator, we're going to do 10 choose 7. Let me go back and get my calculator. So I'm going to type in 10, math, probability, choose, and we're choosing 7, enter. 120 different, wow, collections. So 120 different collections of courses will satisfy this. So I can take, yeah, in 120 different ways. That's kind of crazy. All right, next problem. Go ahead and write this one down. Pause it. When everybody's ready, we'll come back. Okay, we're back. How many different 5-card hands are there in a deck of 52 cards? 52 is my total. 5 is what I'm choosing. So I'm going to say 52, choose, 5. This is going to be a big number. This is going to be a really big number. I'm guessing, I don't know, in the millions? Not sure. 2 million? I don't know. So first number, 52, math, go to your probability, go down to combinations. We're going to check them pull them 5 at a time. Ooh, good guess. So we have 2,598,000, 960 different hands of 5 cards. Okay. Next one. Go ahead and write this guy down. When you are done, come on back. All right, you're back. We've got 8 student representatives and they want to choose a committee of 3. Choose a committee of 3. So there's my choose. 8 is total. So we're going to have 8, choose 3, and plug that in your calculator. I hope you get 56. Okay? So there's 56 different ways to pick a committee from 8 representatives. Last but not least, this is how I terrorize you, right? Go ahead and write this down. When you're ready, come on back. All right, welcome back. I have way more than 32 songs, but I picked something reasonable. I've got 32 total songs on my 80s playlist, and I'm grading papers, and I want to pick 7 songs to shuffle through. It always makes me feel better. So the question is, how many different ways can my playlist play those 7 songs? This is crazy, but this is really what that shuffle does. So what do we have? 32. Choose 7. And how many different orders? Wow, that's a lot. 3,365,856. Let's double check that. That's what I got last night, but 32, math, probability, go down to choose, and how am I picking? Just 7? Yeah, that's a big number. 3, 3, 6, 5, 8, 5, 6. Okay. Moving on. I'm going to go back and review from Friday what permutations are. Remember, in a permutation, order matters. Remember, order matters, okay? So our notation from Friday was NPR. N is my number of objects, and R is the number that are choosing. That's the same. Here, though, order absolutely matters, okay? So I want you to write this guy down. Pause it. You can come back when you're ready. Okay, welcome back. You have 6 different tasks to complete on your to-do list. How many orders can they be done? How many am I choosing, guys? I know what my total is. My total's 6. How many am I choosing? I need to do them all. So I'm choosing 6. Well, that's kind of weird, but it works out. What is 6p6? Let's plug that in our calculator. Then I'm going to come show you something else. So I'm going to do 6, math, probability, permute. Oops, enter, 6. I get 720. This is the same as if I use the fundamental counting principle. And I said, what's 6 times 5 times 4 times 3 times 2 times 1? And how do you do a factorial in there? Let's do 6, math, and let's go find our factorial. Six, math, number, factorial, 720. Okay, so that was a trick question. It's 6, permute 6. All right, let's go on to our next problem. We've got jurors at an art exhibit. They have to select first, second, and third place. When you hear order, first, second, third, it's a dead giveaway that we have to use a permutation. Order matters here. Order matters. So this is pretty easy if we think about it. Here's first place, here's second place, here's third place. We have 35 people. 35 paintings in for first place, which means there's only 34 for second place, which means there's only 33 left to choose from for third place, which is a total of 39,270 ways. Well, the other way that we can get this number is 35p3, and 35p3 will yield that same result. Let me prove it to you. 35p3, 35, math, 39,270. I'm on a roll. I have not made a mistake yet. All right, last one. How many different batting orders are there for a 9-player baseball team? So I've got 9 positions to fill with 9 players. I can put 9 different guys in the first, but now I'm limited to 8, 7, 6, 5, 4, 3, 2, 1. So 9 factorial, or 9 permutation 9. I'm just going to go calculate 9 factorial, okay? So 9 math probability, whoops. Go get my exclamation point. Ooh, it didn't like that. 9 math. Nine factorial. Ooh, 362,880 different lineups. 362,880 different lineups. Okay. All right, that is it. Your classwork. You have the rest of the period to work on problems 1 through 15. This is due tomorrow at the beginning of class. Okay? Please work in pairs and work smart. You should be able to get this done. If you don't finish it in class, it's due tomorrow. Okay? Have a lovely evening, and I can't wait to see you on Tuesday. Bye, guys.